Let me go for a second problem of the same set. Let me tell you people that this particular question appeared in 2016 annual paper. Calculate delta G naught for the following reaction. Reaction is given, let me write it, Fe plus 2 aqueous, Ag plus aqueous is giving you Fe plus 3 aqueous plus Ag solid, given E naught cell 0.03 volt. Let me start the discussion. You can see delta G naught you want to calculate. So let me write formula of delta G naught. Once again, logically let us write formula. You know that it is an energy change, always decreases with the time. Decrease is negative. Energy change in the galvanic cell, it is due to the flow of N Faraday of current across the circuit, and you know that current flow takes place across the circuit only when there is a potential difference, and we call this potential difference as cell potential. Standard is given, so let me mention standard. The formula is ready. Let us do the substitution. Minus n. Now everybody see here the value of n. Plus 2 become plus 3, there is a 1 unit. You can make out. Plus 1 becomes 0 is a 1 unit. Is there any multiplication, division is required? Absolutely no. So you can see the 1 unit, the number of units in both the case is same. So I have to consider the value of n as 1 unit. Faraday's constant, of course it is not given, so what we are doing is we are just taking from our memory list the value of Faraday's constant. So it is 96,500 coulombs per mole. E naught of the cell, it is given ready made. So let me do only the substitution. The answer, you should get it in negative. So let me do the simplification. We have 96,500 into 96,500 into 0.03. The answer that I got here is 2,895. You know that it is energy in joules per mole. It's done. So question number 2 is also done. Let me go to the question number 3, and I picked this particular question from annual paper of the year 2017. So let me clear this. Okay, so the question number 3 from the numerical list, 2017 annual paper question. Let me read it. Calculate the standard free energy change for the reaction occurring in the cell. The cell representation, let me show it. The concentration of the zinc ion in solution is given 1 molar. We have nickel ion whose concentration is 1 molar. Then we have nickel. It's clearly given E naught of the cell. 1.1 volt. We have Faraday's constant, value is mentioned 96,487 coulombs per mole. Let us start calculation. Once again the same thing, the routine, delta G naught. Energy change decreases with the time. Energy change in the galvanic cell, it is due to the flow of N Faraday current across the circuit. You know that current flow across the circuit is due to the cell potential in the cell. Standard, let me mention, delta G naught is equal to minus, see this, 0 become plus 2, there are 2 unit change. You can see plus 2 becomes 0, there are 2 unit change. The value of N, 2 unit, so it must be 2. Please don't mention now the value of F as 96,500 because particularly it is given in the question paper itself. The value of F is 96,487. So whatever given, please you see that you are substituting the same. So into E0 cell is also mentioned in a data list. So this is equal to, you can see answer, you will get it in minus. Let me take simple calculator and let me start doing the simplification. 2 into 96,487 into 1.1. And the answer that you will get is 21,227.4. I'm sorry, it's 2,12,271.4. Energy is in joules per mole. Simple. So let me go for the next one. It's question number 4 I'm discussing now. Let me write it over here itself. And let me tell you that this particular numerical appeared in annual paper in the year 2019. Calculate the value of delta G naught at 298 Kelvin for the cell reaction. The cell reaction I'm writing now: 3 magnesium solid, 2 moles of aluminium ion in an aqueous medium. That will gives you 3 magnesium ion in the aqueous medium plus 2 aluminium in the solid state. The data they have mentioned, standard electrode potential of magnesium system is minus 2.36 volt. Standard electrode potential of aluminium electrode system is minus 1.66 volt. The Faraday's constant, again they have mentioned 96,487 coulombs. So let me go for simplification after writing formula in a first site. You see now I am calculating delta G naught. You know that it is a standard free energy change. Energy change decreases with the time. You know that energy change in the galvanic cell due to the flow of N Faraday current across the circuit, and this current flow possible only when there is a cell potential in the galvanic cell. Standard is given, so I should mention the standard. Delta G naught is equal to minus, let me tell you the value of N now. See this, 0 become plus 2, it is 2 unit. Plus 3 become 0, it is 3 unit. Correct? You can see number of units are not equal. In order to equalize them, I need to multiply 3 here and I need to multiply 2 here. 3 2s are 6 unit. And 3 2s are 6 unit. Now you can see the value of N is 6. Fine. Now the value of Faraday's constant they have mentioned. So please follow the same. Into E naught of the cell. E naught of the cell, I need to do the calculation. So everyone see this. We have electrodes. One of it is anode. Another one of it is cathode. Now please see this. Magnesium 0 become magnesium plus 2. It is increase in oxidation number. We know that it is anox. So magnesium electrode system is anox and aluminium electrode system is red cat. The moment you see E naught anode, E naught cathode, we need to do the calculation of E naught of the cell. So let me write here. E naught of the cell is E naught difference. I told you to remember redox. We know it is red cat. It's anox. It's anox. So E naught of the cell is E naught of the cathode. I can see minus 1.66. Minus E naught of the anode is minus 2.36. Minus 2.36. Now please look at this. E naught cell is equal to minus 1.66. Minus of minus become plus. You get simplification. You can see higher value is positive, smaller value is negative. So difference will comes positive. So let me do the simplification. 2.36 minus 1.66. There is no ambiguity. The answer that you should get is 0.7. Potential is always volt. So most of the students, they go wrong in this particular step. So they will forget to write minus inside. It is minus 2.36 without fail you need to write, so that a negative into negative become positive, and answer you will get here at this particular specific problem, it is 0.7 volt. Now I can do the substitution of that particular value over here. My final answer, it will comes in minus. So always what you do is mention this first, because there is a chances that you may forget to write the symbol. Please write minus first, then you take calculator and work out the last step. It is 6 into 96,487 into 0.7, and the answer that you will get here 405,245.4. You know it is energy, that is in joules per mole. It's done. Okay, yeah. Let me take next question, and I think now I can give you homework. Solved example of NCERT. I'm giving it as a homework question for you people. So let me write it. Everyone take the fifth question. It is solved example of NCERT textbook. I'm reading question. Standard cell potential for the Daniell cell is 1.1 volt. I'm repeating, standard cell potential for the Daniell cell is 1.1 volt. Calculate the standard Gibbs energy of the reaction. Let me write the reaction here. Zinc solid reacting with the copper ions in the aqueous medium, that is giving you zinc ions in the aqueous medium, and of course the byproduct is copper in the solid state. Fine. This is the homework question for you people, which is actually solved example of your NCERT textbook. There's one more homework question let me give. Question number 6, please take it. Question number 6. Let me read the question. Calculate the maximum possible electrical work that can be obtained from the following cell under standard conditions at 25 degrees Celsius. Let me show you the cell representation they are giving. Zinc ion, salt bridge, nickel ion and a nickel. It is given standard zinc electrode potential minus 0.76 volt and standard nickel electrode potential value is minus 0.25 volt. So this is a one more homework question. So there are two homework questions for you people. One is NCERT solved example. The another one is question on work done. Let me tell you people very clearly that to calculate the standard free energy change and for calculating work done in the galvanic cell, the formula we are using is same. But the thing that you need to remember is whenever we are calculating energy change, we know that for a spontaneous reaction, it decreases with the time. Decrease is negative. So standard free energy answer, it should be mentioned in negative. When it is work done, please write work done value in positive. So this is what a very clear point that you should make out. Otherwise, there is a possibility of you may lose mark for the sign convention. So standard free energy change negative answer and work done positive answer. Fine? Yes.